This video was produced by Alabama View, a member state of the America View, a consortium dedicated to promoting remote sensing outreach, education, and research, funded by United States Geological Society or USGS. Its contents are solely the responsibility of the authors and do not necessarily represent the official views of America View, the USGS, or other partners. The mention of trade names or commercial products does not constitute their endorsements.
Hello everyone. Welcome to part 2 of our video series on urban expansion. In part 1, we discussed the pattern, extent, and future trend growth of the 10 largest cities in Alabama. In part 2, we will focus on the tools and techniques used to delineate the growth of cities in Alabama, which means we will learn about the techniques involved in finding out how the Alabama cities have grown over the years and how we could achieve these results. We will begin by learning about the land use and land cover change detection for the 10 cities of Alabama with the time series change visualization. We will also learn about the land change modeler of Terset software that was used for the future urban growth prediction for all of the 10 cities of Alabama. ArcGIS was used for the land use and land cover change analysis for the 10 cities from 1982 to 2019, and Terset was used for the future growth prediction of the urban area expansion to 2040. Landsat images 6, 7, and 8 from the years 1989, the 1990s, the 2000s, 2010, 2015, and 2019 were downloaded from the USGS Earth Explorer. You can learn how to download these images here. The images were then used for detecting the change and predicting the urban area expansion for 2040. They were imported in ArcGIS to conduct supervised classification of the images to detect the changes. You can learn about supervised classification here. Raster images such as elevation, slope, aspect, distance from road, distance from water, and distance from settlement are also needed and can be created from existing raster and vector files. The elevation file was downloaded from the NASA Earth data called Aster DEM, which was then imported into ArcGIS. The inbuilt tools in ArcGIS with predefined calculation algorithms were used to create the slope and aspect raster. And the GIS layers of road, water, and settlement were used to create the distance from water and distance from settlement in Terset software. The classified images of 2010 and 2015 were then used in the Terset software with driver variables such as elevation, slope, aspect, distance from road, distance from water, and the distance from settlement to conduct a future change analysis. Validation is an important step in any remote sensing analysis. As remote sensing includes either human or computer interpretation, it is necessary to validate the results to understand the accuracy. The classified image of 2019 was used for validation of the model created. The image shows the hits, misses, and false alarms of the pixels the model created for the year 2019 against a classified image of 2019 using supervised classification. It paints the picture of how accurate the model is. We see a visual representation of potential changes in these cities with the help of this technology. You can learn more about using Terset from the following videos. Hence, using remote sensing can be beneficial to city planners, architects who want to build sustainably, city officers, and any other stakeholder or practitioner who has an interest in the planned growth of cities. If anyone doesn't have access to softwares like ArcGIS and Terset, which requires purchase licenses, then they can use open source GIS software like QGIS, open source remote sensing software like Saga, or growth models like Sleuth. These are some examples of softwares that are open source and free to use. Thank you for watching our video, and we hope to see you in the next one. If you like our content, please make sure to like and subscribe so you never miss out on our next video.